Hello, I'm Mrs. O'Brien. Welcome to my video on simple polygons. Please find this simple polygon page in our OneNote class notebook. Fill it out while you watch the video. This may be easier if you have two devices, one you are watching and one that you are able to annotate the PDF. You could also do this on a piece of paper. Remember, this is a video and you can pause it at any time. Simple polygons have sides made of segments. The sides are always straight and never curved. Their endpoints connect at vertices. A vertex can connect only two sides. Segments that connect opposite vertices are diagonals. If one side is extended, an external angle is created between that side and the adjacent side. Here are some examples of polygons. They are made up of line segments that are closed figures. These are not polygons. This one is not closed. This one has a curved section, so it's not made up of complete line segments. This one is also not made up of only line segments because it has a curved portion. And this one crosses itself. Now let's look at convex versus concave. So convex, all the vertices are outside and they have no dents or no indents. So notice these orange dots are the vertices and they're all on the outside of the polygon. Where concave, we notice here our vertices kind of goes dented in. So I kind of connected the two vertices with a dotted line so you can see that there's a vertice that actually goes in or dents in like a cave. So concave. Equilateral polygons are when all the sides are congruent. So when all sides have equal measure. So these hash marks are showing that all the sides are the same length because they all have one hash mark. And here they all have two hash marks showing that all those sides are congruent. Equiangular means all the angles are congruent in the polygon. And regular means both of these are happening. Both the sides and the angles are congruent. So for our triangle, that would be an equilateral triangle because in an equilateral triangle, all the angles are also 60 degrees. And in a square, all sides are congruent and all angles are 90 degrees. So those would be two examples of regular polygons. In a triangle, we have three sides, and the sum of all of the interior angles would be 180 degrees. If it is a regular polygon, meaning all the sides are congruent, then all the angles are also congruent if it's a regular polygon. So if one of them is 60, they would all be 60 because 180 degrees divided by the three angles would give me 60 degrees. And the exterior angle is always supplementary, forming a linear pair or a straight line. So 60 degrees plus 120 degrees gives us the 181st straight line. So if we know the interior angle, we can find the exterior angle by subtracting it from 180. So I proceeded by filling in the name of the polygon, the number of sides, the number of diagonals it would have, the sum of the interior angles, the measure of each of the interior angles if it's a regular polygon, and then each exterior angle if it's a regular polygon. There are no mentions of diagonals in this one because there is no vertice that I can connect to another vertice that wouldn't already be a side. Unlike in a quadrilateral where I could take a vertice and connect to another vertice with it not being a side. I would like you to continue and fill in these other polygons with their names, the number of sides they have, the sum of all of the interior angles, and then what the measure of each interior angle would be if it was a regular polygon, and then the measure of the exterior angle if it was a regular polygon. Thanks for watching. My resources for today's video were a note guide I adapted from Miss Jude Math on simple polygons.